Hey everyone, I'm Kaushik. Whether you're joining me from home, the office, or maybe you're watching on the toilet, I hope you're as excited as I am to talk about GCP and Azure logs. Before I explain what low-hanging logs are, or why I've developed a talk for lazy people, let me go ahead and give a quick introduction about myself. So about me, I'm an undergraduate student at UCLA studying computer science, but I've been a consumer of cloud providers for an extremely long time. Back in 2013, I used to set up Minecraft servers on AWS, so I remember what the first AWS console looked like. Currently, I'm a sponsored researcher in the UCLA Connection Lab, and I'm working on formal methods for cloud security. On the more practical side, I'm also an intern at a cloud security startup called Dassana. We're building a security data lake, and some of my responsibilities at Dassana include ordering coffee, making sure it comes on time, making sure engineers are well hydrated, and occasionally breaking things. So previously, security, 5-10 years ago, people would look up terms like Linux security, Windows security, MySQL security, or learn how to do IP tables. You might learn to analyze different processes, or in Windows, learn how to secure your Active Directory. Now, the cool part about how security was done before is if you learned Linux security at one organization, then you move to another organization, the principle is still typically applied. The knowledge transfer was there. But today, this is a kind of the classic graph that everyone shows. There's a lot of different cloud providers, and AWS has typically been the king of clouds, but in recent years, Azure and Google have been catching up. Now, the problem with this is that there's a phenomenon which I like to call cloud bleed. Say we have company foo, and company's foo's infrastructure typically looks something like this. 90% of the organization might be on AWS, but say the data team might be on GCP. Now, this is a problem because the way you do security in AWS is so different from other cloud providers. So if we take a look at this Venn diagram, all of your security focus might be on AWS. Your security team, your developers might be really good at setting up SCPs, doing least privilege for IAM inside AWS. But you have 10% of your infrastructure on GCP. And this, again, might not receive much attention, or engineers might not have much experience securing GCP or learning how to do detection and response on GCP. So, of course, your organization is only as secure as your weakest link. So your GCP infrastructure is likely to get breached. And when your infrastructure does get breached, customers don't care that, oh, my AWS infrastructure was secure, but my GCP wasn't. All they care about is your infrastructure was breached and their data might have been at risk. So let's go ahead and jump into a practical example. Let's say you just got a security alert. Which of these questions are immediately important to answer? Remember, we're doing a talk for lazy people. We don't want to answer all the questions. We just want to answer what questions are immediately important to us right now once we get the alert. I'd like to argue that the most important questions to answer are who and what. Who did it and what did they do? The question of where is typically answered by an IP address. When is when, a timestamp. Why? Well, that goes into the psychology of a hacker, which we're not really interested in. And how is something more of a remediation exercise, which we can only do once we've figured out the scope of the breach. So in the cloud world, I'd say that who is a cloud identity. In AWS, this could be a access key or a ARN of a role. And what are the cloud API calls that this identity has made? So let's go ahead and jump into a GCP log and try to answer the questions of who did it and what did they do. Before we can answer these questions, we need to make sure we have logging enabled. And I'd like to share a horror story that I've seen in the past. In a previous internship at a Fortune 500 company, this company is running a lot of their infrastructure on GCP. And we did a quick exercise to see of the projects they had, how many of these projects had cloud audit logging enabled. They had over 600 odd projects, and only about 100 of these projects had cloud audit logging enabled. So this is really bad. If you only take one thing away from today's talk, please go ahead and enable cloud logging in all of your production projects. As you can see, the right-hand columns are admin read, data write. These are basically analogous to CloudTrail's management and data events. So if you're concerned about, I have too many logs, it's going to cost me too much to put all these logs in my SIM or wherever you're storing it, go ahead and only enable the management events. The data events can be quite noisy, but if you really truly care about complete security, I recommend enabling everything. Okay, so if you're familiar with AWS, you're probably familiar with CloudTrail, which is where almost all of your security data comes from. And in GCP, the analogous log to CloudTrail is the cloud audit log. Now, I've truncated the log to only show the authentication info section, and this is going to describe who did it. So the most important field in this authentication info section is principal email. If we're trying to answer the question of who did something, your first instinct might be, okay, the cloud audit log has the principal email. All I have to do is check that, right? Well, let's go ahead and look at a sample principal email. Now, this doesn't look like any email I've seen before. My email is kdev@ucla.edu or kaushik@dassana.io. I have no clue what this email is or who controls this email. So to answer this question, we're going to have to take a look at the classes of GCP principals. So there are two main classes, users and service accounts. Users get their credentials issued by Google, which means they have to hit the Google Identity server. Typically, they're OAuth 2 tokens, and they're designed for human use. So if a user took an action that created a log, the principal email would look like, again, like kdev@ucla.edu, kaushik@dassana.io, etc., like human readable emails. Now, there's another class of GCP principals, which are far more common, and these are machine identities. Typically, these are credential files that contain the private key, which can create their own credentials and exchange them for tokens. And the principal email for service accounts looks a lot more like the super long email we saw in the log before. So now let's go ahead and look at what our log where a service account is called the list secrets API. And remember, a service account email, principal email looks like this. I'll go ahead and pause for like 20 seconds. And I want you guys to think about what's wrong with the service account calling list secrets. Okay, so of course, accessing secrets is always a sensitive issue, but service accounts should be calling get secrets. Remember, they're machines. They're not like waking up and deciding, oh, let me see what are all the secrets I have and then picking one. People have coded service accounts to go ahead and grab one secret that they need. They're going to keep grabbing that same secret. They're not supposed to enumerate all the different secrets I have. This clues us in to think, hey, maybe the service account has been compromised by a human and is being used to enumerate all the different secrets I have. So if we go ahead and look at that same cloud audit log that had the principal email of our service account, there's another field called service account delegation info. So remember, we've looked at so far the authorization info field. The other important field, which is the second piece of the puzzle to who did it, is service account delegation. You can think of this kind of like assume role in AWS. So a service account delegation will either have a first-party principal or a third-party principal. A first-party principal means they've directly logged in via Google Identity server. So this can be like I've logged in through the console. And as you can see, my principal email is kdev@ucla.edu. And I've been delegated access to the service account below. A third-party principal means they logged in through an SSO provider. So for example, they logged in through Ping Identity or OneLogin. Now the picture becomes more clear. There has been a user account, which is me, and I have assumed a role in AWS terms. In GCP terms, that would be I've delegated into a service account, which called the list secrets API. But going back to that previous log, what if the principal email, which delegated into a service account, was a service account itself? Now you can see the problem. There can be a long chain of identities that have assumed roles into each other. How do we go ahead and track this down effectively? Because looking at each log, looking at the log that called list secrets, we're not going to be able to find the user that has jumped or moved laterally to call this API. We can go ahead and use Google's Log Explorer to do this. So if you've enabled cloud audit logging, all of your logs go into Google's Stack driver. Now it's called cloud logging. And you can go ahead and look for access tokens that were generated. So each time you delegate into a service account, if you say you're accessing from the CLI, an access token will be generated and used in subsequent API calls. So if I go ahead and search for generate access token, we can see that there's a bunch of logs with the method name generate access token. And inside these logs, we can find that my principal, kdev@ucla.edu, requested to jump into this final service account. So now we've kind of solved the puzzle of this identity chain. So again, remember that GCP service account impersonation is analogous to AWS assume role. So now that we've answered the question of who did it, the next question is to answer what did they do? Now, again, we're back in Google's Log Explorer, and I want to figure out what are kind of all the actions that have been taken by my user account or the service account that I have assumed. In Google, you can create these summary fields, and essentially this is kind of works as a way to surface up different fields from the JSON. So if I ran that query, this is what would come out. Now, as you can see, there's way too much noise to figure out what has happened. Every action I take in the console can generate like 10 to 20 events in here. As you can see, these are all pretty much useless events from a security point of view. I don't care about listing clusters or going into the resource billing console. So what I'd really like to do is run this query again, but group by all the different API methods that have taken place. So what this will do for a service account typically only is calling 3 to 4 APIs. And if I group by the method name, I'll be able to see, are there any anomalous methods that have been called? The problem is you can't do something like this in Google Cloud Logging. You can't actually do group bys. So this means it's really difficult to analyze historic data. And for this reason, I'd like to bring up the point that if you really want to perform useful security queries on your security logs, you need a platform that supports an expressive query language. So I'm going to go ahead and show an architecture of how you can do this. So cloud logging, you can ship your logs to a sink. And a sink is essentially a way to aggregate logs across all your different GCP accounts. In an AWS world, you can think of this as an org trail for CloudTrail, but for any arbitrary log you want. And if you want to stay within GCP, that's great. You can take your sink and set BigQuery as a destination. BigQuery supports these kind of operations like group by. I also would recommend that if you really want more security features, you set the destination of your sink to a pub subtopic and ship it out to a SIEM like Splunk, Datadog, Sumo Logic, or Dassana. Remember, I work at Dassana, so take this with a grain of salt. But I want to illustrate why I think it's important to ship these logs out to the SIEM. One big reason is detections. So remember, we kind of came up with this heuristic that since a service account is a machine, it shouldn't be enumerating resources. It should only be getting specific resources. So can we exploit the fact that we know that service accounts are machines? Now here's kind of where GCP security is better in a sense than AWS. In AWS, it's hard to tell sometimes when a role or an ARN is a machine identity. Sure, EC2 instance profiles are often prefixed with EC2, but they can be renamed. So it's hard to create a detection on an ARN and and make them specific for machine identities. Whereas in GCP, we know when we get a service account that this is a machine identity. So it allows us to create really high fidelity queries. So let's take a look at this example. A user calling get on any storage API or list on any storage API is completely fine and valid. And a service account calling get on a storage API, again, is completely fine. But what about when a service account calls list on any sort of storage API? This should, cause an alarm, a red flag. So what we've done at Dassana is we're starting to build a bunch of these detections where anytime a machine identity is calling these enumerate APIs in GCP or in Azure, we're go ahead and send a notification to you, alerting you that, hey, potentially this service account is breached. We're planning to make these detections open source and public in next month, so keep an eye out for that. Now let's quickly jump into Azure. If you remember from our cloud audit logs, we answer the question of who with authentication info. And in Azure, we answer that same question in Azure activity logs and resource logs. Activity logs are the control plane operations, and resource logs are the data events. The most important thing to enable is activity logs, but if you do have the budget in your SIEM, you should enable resource logs as well. The most important field in Azure is caller, and this kind of lines up with the principal email of GCP. Now, you might start to wonder, wait, how many of these fields are kind of shared among log types? Do I really have to learn that principal email in GCP is the same thing as Azure, caller in Azure is the same thing as user identity in AWS? Is there any way we can kind of make this easier? And my answer to this question is cloud normalized fields. Again, remember, I'm super lazy. I don't want to have to learn all the specific names of all the specific fields in AWS, Azure, and GCP. All I want to know is a certain field is an identity, a certain field is a method, etc. So the motivation behind cloud normalized fields is the following question. I want to find all the actions in all my logs across all my clouds taken by an identity. How do I do this? Well, one way is to write three separate queries like this. The top one is for CloudTrail, and I'm selecting all the events where the identity could be the account ID or the username or the principal or the ARM. And in GCP, we just learned that in cloud audit logs, the identity could be contained within the principal email of authentication info, the principal subject of authentication info, or service account delegation in authentication info. And in Azure, again, it could be within caller or the authorization role. Now, writing this query took me about like 8 minutes. I had to go to each CloudTrail documentation, GCP documentation, and Azure activity logs documentation, find all the relevant fields, and then write out this query. Is this really the easiest way to do this? Can we do better? And the way that I'm thinking about this is all of these logs share certain fields, CloudTrail, cloud audit logs, and activity logs. They're all audit logs and they all share certain fields. And here are the fields that I found they all share in common. Event time, they all have an identity, they all have a source IP of the identity, an action that the identity took, the resource type, which the action was taken upon, and the resource name, which the action was taken upon. Now, what I've done is I've mapped all of these three different logs to this audit log schema. For CloudTrail, I've done this exercise for CloudTrail, cloud audit logs, and activity logs. And this is all open source. I'll be pasting a link in my Slack channel after. Now, what we can do is we can answer this question in a much simpler way. Again, we're trying to find all the actions and all the logs across all my clouds taken by a specific identity. What we can do is write the following query. Select action from audit logs where identity matches some identity. And now that we have these YAML files that contain the mappings of these different cloud logs, we can write code that expands these different fields into that ginormous query we had before internally. So no longer do we have to remember that in one log that it's called principal email, and another log it's called caller, we can leave that all up to, we can simply write this simple query and have code expand this query into something that answers this question. So this doesn't just apply to audit logs. I've done the same exercise for flow logs, again, mapped in that GitHub repo that I'll be pasting in the Slack channel. So VPC flow logs in AWS and GCP, and NSG flow logs in Azure. So what we can do is select star from flow logs where IP is some IP. So across all my logs, across all my clouds, I can find where a certain malicious IP shows up. So today we've mapped audit logs and flow logs for 3 cloud service providers. What I really want to do is work together as an open source community to expand this coverage for log normalization. Not only does that mean expanding to other clouds like IBM or Ollie Cloud, but I also want to expand all the different log types we have, getting S3 access logs involved, etc. And you guys are all security experts, so I hope we can all come together to build this tool. If you'd like to join Dassana and help us build a security data lake, please check out the hiring section at dassana.io or email your resume to careers@dassana.io. And thank you for listening.